Good morning, each and everyone. I am Christian John Indugus, and I am here to report the Chapter 9 Functions. So, what is function? Function, in simple words, a function is a relationship between inputs where each input is related to exactly one output. So, the function is the one that relates or connects a set of numbers in particular way in order to get its pair of numbers. And also, it is the one who connects or explains how two variables related to each others. A function is generally denoted by f of x, where x is the input and the f is not a variable to be multiplied. It is the name of a function. So take note lang guys ha, ang f is dili siya variable nga i-multiply nato sa x. So ang f diri is name lang siya sa function. And dili siya to be multiplied sa x nga variable. And function is also ordered pairs of x and y. So the next reporter will explain why it is necessary to a function is needed to be ordered pairs of x and y. Simply shown on the picture, a function is a rule which establishes correspondence between two sets, where the first set is the domain and the second set is the codomain. As I said earlier, the function is kita siya sa tunga or siya ang only way para ma-solve ang output sets. So here are the sample of sets. This is the sample of sets where the one in the left side is the domain or the input or the independent variable, and then the right side is the output or the dependent variable or range. So as makita nato sa picture is there is an arrow diba ng red or line, and siya ang nasa tunga, siya ang function. Ang function is diba, as I've said earlier, is ang function is the one that connects or relates the input and the output, or the one who connects the domain or codomain, the one that connects the independent and dependent variable. So sa makita nato sa picture is dili pwede nga ang isa ka variable is mo connect isa ka input is mo relate to another output, diba? And sa makita na sa picture is ang one input is also connect only to one input lang, dili pwede mo connect ang another input into two outputs or three output, because ang one input is equivalent only to one output. So unsa yun din ng function? So ang function is usually it is an equation in order to solve the y or the dependent variable. So nganong ang y is gitawag na siya dependent variable, because ang y is naga-rely siya sa equation sa dependent sa independent variable and sa equation which is ang x and ang function. And also ang x is, we call it independent variable because we can plug in any number nga pwede na to ibutang sa x. That's why we call it independent. However, ang y variable is nagadepende siya kung unsay i-plug in nato nga number sa x. So here are some examples. Example number 1, if f of x is equals to 4x squared plus 9x plus 11. So ang function na to diri is simply ang whole equation, which is ang 4x squared minus 9x plus 11. So mo na siya atong function. Ang atong x diri or ang input nato is ang x. So ang x is independent variable siya. So ang independent variable is naga-realize sa ito kung unsa atong gusto ibutang nga number para makuha na to ang iyahang output or ang dependent variable. So example lang ato ang x is depende man sa to atong ibutang. So ang example sa picture is 1 akong ibutang. So ang x is sa whole equation, ang x is i-substitute na to siya sa 1. Okay, moment nakabutang sa f of 1 naman siya. So equals to 4 times 1 raised to the power of 2 minus 9 times 1 plus 11 is equals to 6. So ang ato ang input is ang 1 and ang ato ang function is ang whole equation. Ang ato ang y or ang dependent variable is 6. Example number 2, if f of x is equals to x squared plus 2x minus 9 all over x minus 3. So remember guys, ang ato ang whole equation diri is the function, because it is the only way lang para makuha nato ato ang dependent variable, which is atong y variable or ang dependent variable, di ba? Then as shown sa picture, ang akong gigamit na x, ang input is 0 kay di ba as I've said earlier is ang atong input or ang atong independent variable is nakadepende lang sa unsa atong ibutang, unsa atong i-plug in. Mo na siya mong independent variable ang tawag siya, ha. So if f of 0, so f of 0, which is ang x ato is sa whole equation, ang tanan x atong makita is i-substitute na to into 0, which is 0 squared plus 2 times 0 minus 9 all over 0 minus 3 is equals to 3. So remember guys, ha, ang ato ang whole equation is the function, and the 0 or the x is ang ato ang independent variable, which is nagadepende sa to kung unsa atong ibutang or nagadepende sa problem. And the number 3 or the equals is the dependent variable, which is naga-realize lang siya sa unsa ang ibutang sa input o unsa ang equation or ang function nga gigamit. So simply shown in the picture, it simply denotes as f of x equals to y. So ang f3 is, always remember, is the function, and ang atong x is the input, which is ang atong independent variable, because naga-depende sa to kung sa atong ibutang, and ang atong y is the output, which is nagalilay siya sa function and sa independent variable. So always nato i-remember guys that when x and y are allowed to assume only real value, y or f of f of x is called the dependent variable or the value of the function, while x is called the independent variable or the argument, and the function itself a real valued function of a real variable. So this is the example number 3. Let the domain of x be the set of 0, 1, 2, 3. Assign to each value of the x number y is equal to 2x plus 5. So ang ato ang independent variable diri is ang 0, 1, 2, 3, which is the x or the domain. And ang ato ang function is the whole equation, which is ang y is equals to 2x minus 5. And ang y is the dependent variable, which is we need to find in each number sa set sa ato ang x or domain. So sa first is if x is equals to 0, then y is equals to 2 times 0 minus 5, which is ang ato ang dependent variable is ang ato ang number negative 5. Then next is ang if x is equals to 1, so ato ang independent variable is nag-change, which is 1 ang itong ibutang. So the whole equation will be changed. So y is equals to 1 minus 5, which is ang negative 3. Then next is if x is equals to number 2, which nag-change na po ang ato ang domain or ang ato ang independent variable, which is y is equals to 2 times 2 minus 5 is equals to negative 1. Then next is fx is equals to 3, then y is equals to 2 times 3 minus 5, and the dependent variable is equals to 1. So sa makita nato sa example number 3 is ang set of input is only having one output each. So ang input sa example sa set of numbers is only having one output each lang sila. Sa 0 is ang negative 5 yung output, ang sa 1 is ang output niya is ang negative 3, and sa number 2 is ang output niya is negative 1, and sa input number 3 is ang iyahang output is ang positive 1. So it is a function. So always remember that, guys, nga ang x is ang independent variable kay dili siya nagadepende sa uban, which is wala sa tuon sa ibutang. Then ang function is the whole equation, and ang ato ang y is ang dependent variable, which is nagadepende siya sa equation and sa input atong ibutang. So lastly, guys, is ang function is nagagana lang siya kung ang set of number or set of input natong ibutang is dili nagabalik-balik. Kay if ever nagabalik-balik ang atong set of numbers or names si isa diya nagabalik-balik, is ang atong output is mapektuhan sad. That's why dili na siya function. It is called a relation. And that concludes my report. Thank you.
So now let's talk about operations of functions. So functions can also be constructed from previously defined functions by using the algebraic properties of the real number system. So in doing the operations of functions, we must use the fundamental operations, which is the addition, subtraction, multiplication, division, letting f and g be the functions. So there are 4 conditions in doing the operations of function. The first condition is their sum, denoted by f plus g, is a function defined by f plus g of x is equal to f of x plus g of x. The second condition is their difference, denoted by f minus g is a function defined by f minus g of x is equal to f of x minus g of x. The third condition is their product, denoted by fg, or the combination of f and g, is a function defined by fg of x is equal to f of x multiplied by the g of x. The fourth and last condition is their quotient, denoted by f over g, or f divided by g, is a function defined by f over g of x is equal to f of x over g of x. Well, each of these functions has its own domain. The set of all values of x, which are both in the domain of f and in the domain of g, with an additional requirement for the fourth condition, where values of x for which g of x is equal to 0 are excluded, because g of x being placed at the denominator of the function, g of x must not be equal to 0 unless the result of the function will be undefined. So here are some examples. Example number 1. Let f of x be equal to x squared and g of x is equal to 8x plus 2. Now find f plus g, f minus g, fg, and f over g. So let's go to the solutions. First is the f of g of x. F of g of x is equal to f of x plus g of x. Now, let's substitute the value of f of x into x squared and the value of g of x into 8x plus 2. Now, the answer is f plus g of x is equal to x squared plus 8x plus 2. So, let's go to the second solution for the f minus g. So, f minus g of x is equal to f of x minus g of x. So, just like what we did in the addition, let's substitute the value of f of x into x squared and the value of g of x into 8x plus 2. So f minus g of x is equal to x squared minus the quantity of 8x plus 2. So f minus g of x is equal to x squared minus 8x minus 2. The third solution is for the multiplication, the fg. So fg of x is equal to f of x multiplied by the g of x. So simply substitute the value of f of x and g of x. So the final answer is fg of x is equal to x squared multiplied by the 8x plus 2. The fourth solution is for the division, f over g of x. So f over g of x is equal to f of x over g of x. So f over g of x is equal to, again, let's substitute the value of f of x and the g of x. So we can get f over g of x is equal to x squared over 8x plus 2. So the final answer is f over g of x is equal to 8 squared over 8x plus 2. So to sum it up, The operations of functions encompasses a set of mathematical actions that can be performed on functions. These include using function notation to represent relationships, composing functions, adding, subtracting, multiplying, and dividing functions, as well as exploring the concept of inverse functions. These operations offer a versatile toolkit for manipulating and analyzing functions in various mathematical contexts.
So the composition of functions. Let f and g be functions. The composite function of g on f, denoted by g composed of f, is defined by g composed of x is equal to g of f of x, and f composed of g of x is equal to f of g of x. So the domain of G composed of F is the set of all x in the domain of F for which f of x is in the domain of G. So we have here example number 1. Let f of x equals to x squared plus 1 and g of x is equal to 8x plus 2. So find f composed of g and g composed of f. So for our first solution, we will first going to find f composed of g of x, which is f composed of g of x is equal to f of g of x. So the first thing that we will going to do is substitute the value of g of x into f of x. So as you can see, the value of g of x is 8x plus 2, and then we will go into substitute here in f of x. And the next thing that we will going to do is we will gonna use the value of f of x, which is this x squared plus 1. So, but we will going to replace the value of x into 8x plus 2, or the value of our g of x. So as you can see, we have your 8x plus 2 raised to 2 because from here, from the value of our f of x. So 8x plus 2 raised to 2, and then we will gonna copy the 1. So we will gonna expand and simplify. For here, 8x plus 2 raised to 2, we will going to use the FOIL method. So after using the FOIL method, we will have the answer 64x squared plus 16x plus 4, and then we will gonna copy the 1. So we will going to simplify. We will going to add the like terms. So copy the 64x squared and then plus 16x, and then add the 4 and 1. So we have 64x squared plus 16x plus 5. So the value of f composed of g of x is equal to 64x squared plus 16x plus 5. Another, in our second solution, let us find the g composed of f of x is equal to g of f of x. So same thing that we did earlier, but vice versa. So here, since this is g of f of x, the first thing that we will going to do is substitute the value of f of x into g of x. So the value of f of x is x squared plus 1. So we will go into substitute here. That's why we have this. And after that, we will going to use the value of g of x, which is the 8x plus 2. But we will go in to replace the x into the value of f of x, which is the x squared plus 1. So as you can see, we copy here the 8, and then we replace the x here as x squared plus 1, or the value of this f of x. And then we will gonna copy the 2. So we will go into distribute and simplify. So 8 times x squared is equal to 8x squared, and then 8 times 1 is equal to 8. Copy the 2, and then add like terms. So 8x squared, copy, and then add the 8 and 2. So we have now 8x squared plus 10. So the value of g composed of f of x is 8x squared plus 10. So another example is let f of x equals to 2x plus 1, and g of x equals to 5x plus 3. Find f composed of g. So our solution here. So f composed of g of x is equal to f of g of x. So same thing that we did earlier. So for this, since this is f of g of x, we will going to substitute the value of g of x into f of x. So we have here this, as you can see, we substitute the value of g of x, which is the 5x plus 3, into f of x. So after that, we will going to use the value of f of x, which is the 2x plus 1. So here, but we will going to replace the value of x into 5x plus 3. So as you can see, we have here the 2, and then for the x, we replace it as 5x plus 3, or we replace it into 5x plus 3, and then we will going to copy this 1. So, distribute and simplify. So 2 times 5x is equal to 10x, and 2 times 3 is equal to 6. Copy the 1, and then add the like terms. 10x copy, then 6 plus 1, 7. So we have here now the 10x plus 7. So the value of f composed of g of x is equal to 10x plus 7. So another one, let f of x equals to 5x squared minus x plus 4, and g of x is equal to 2x minus 1. Find g composed of f. So g composed of f of x is equal to g of f of x. So again, the first thing that we need to do is substitute the value of f of x into g of x. So the value of f of x is 5x squared minus x plus 4. So we will going to substitute here in g of x. And then after that, we will going to use the value of 2 of g of x, which is the 2x minus 1. So as you can see, we have here the 2, and we will gonna replace the x, or the value of x is as into 5x squared minus x plus 4. So 2 we have here, and for the value of x, we replace it as 5x squared minus x plus 4. And then copy the negative 1, or minus 1. And now we will going to distribute the 2. So 2 times 5x squared is equal to 10x squared. 2 times negative x is equal to negative 2x. And 2 times 4 is equal to 8. Then copy the negative 1. So we will going to add the like terms. 10x squared copy, and then minus 2x copy, and then 8 minus 1 is 7. So we have now here the 10x squared minus 2x plus 7. So the value of g composed of f of x is 10x squared minus 2x plus 7. So we have here the even and odd functions. So a function f is an even function of x if f of x is equal to f of x, or a positive sign. So as you can see, it's the same with the original function. So for every value of x, so an odd if f of negative x is equal to negative f of x. So as you can see, the difference for this even, this is the y-axis, and then for the odd, this is the region. But here, um, what the things that we need to remember is that if the function, or if the answer will be back to the original function, which is like this, f of x is equal to f of x, that is even. But if the function same with the original function but with different sign, that is odd. So we have here example. So example number 1, f of x is equal to x squared is even because negative x raised to 2 is equal to x squared. So here, what we're going to do is we will replace x with negative x. So for x squared, we will gonna replace this x as negative x. So that's why we have here negative x raised to 2, which is negative x times negative x is equal to x squared. So as you observe, the original function is x squared. And if we're going to replace it with negative x, the equal is x squared. So the answer is the same with the original function. So that is even. Again, it's even if the answer or the equal is same with the original function. So next example is f of x is equal to x cubed is odd because negative x times negative x times negative x or negative x raised to 3 is equal to negative x cubed. So here again, we will going to replace, so our original function is x cubed or x raised to 3. And then we will going to replace this x as negative x. So as you can see here, we replace it. So it became a negative x, and negative x raised to 3 is equal to negative x cubed. So as you observe, the original function and the answer. So they have the same x cubed, but they have different sign. So that is odd. Even though they are the same x cubed, which is the answer is same with the original function, but their sign is different. So that is odd. So another example we have here, f of x is equal to 2x squared plus 4x raised to 4. So here we will replace the x as negative x. So f of negative x, and then 2, replace it with negative x. So 2, then negative x raised to 2 plus 4, and then the x will replace it as negative x. So negative x raised to 4. So if we were going to um, simplify all of this, we will get the answer 2x squared because negative x times negative x is equal to positive x squared, which is 2x squared, and then plus 4 times negative x raised to 4. So that is 4x raised to 4. So as you can see, our original function is 2x squared plus 4x raised to 4. So the original function is the same with the answer. That's why it's even. So as you can see, again, if the answer is the same, all the same with the original function, which is this, that is even. So another, we have here f of negative x is equal to 5x cubed. So again, we will replace x with negative x. So f of negative x, and then the same here is equal to 5, then replace the x with negative x. So 5, then negative x raised to 3, and then negative x times negative x times negative x is negative x cubed, and then 5 times negative x cubed is negative 5x cubed. So as you can see also, our original function is 5x cubed, but the answer is 5x cubed but with different sign. So it's odd. Again, our original function is 5x cubed, and then our answer is negative 5x cubed. They are the same 5x cubed, but they have different signs. So that is odd. And that ends for even and odd functions.
So, good day everyone. My name is Sheena Mayerlida and I am the third reporter for this lesson. My topic is still related to function, graph of a function. So, the graph of a function f defined by y equals f of x is the set of all points x and y in a plane. For example, we have y is equal to x squared. So we have to remember that in a function there is an x and y, where x is the input and y is the output. Now we will solve this problem. Y equals x squared. Yes, y equals x squared. So the first step that we need to do is to make a table of pairs from the function. I already put the values of x here, so the next task is to substitute the values of x to the given problem. Okay, so let me have a clean sheet of paper. Okay, here. Okay, now our problem is y equals x squared, right? So I'm gonna write it here. Since we already have the values of x, we will just gonna substitute it to the given problem. So let's start with negative 2. So the value of our x now is negative 2 or negative 2.0. So y is equal to x squared. Then y is, the value of our x is negative 2.0 and then squared. Just solve it. The answer is 4 or 4.0. So we will write the 4.0 in the y table. So if our x is negative 2.0, then our y is 4.0. Next is negative 1.75. So our x is negative 1.75. Then we will just substitute it to the given problem, and then the answer is 3.06. So I'm gonna put the 3.06 on the y table. So if our x is negative 1.75, then our y is 3.06. Same procedure with the rest of the values of x. So in this part of my presentation, I will just make the video fast forward. Now, I have completed the table of pairs from the function. So we have the complete ordered pairs of the function. So the second step is to plot the points. So what we are going to do with this is to draw a Cartesian plane. Okay, so let me draw first the Cartesian plane here. So this is our x and this is our y and the 0 in the center. So after that, we will plot all the points in the Cartesian plane. So I'm sure we all already know how to plot the points. Then I realized that I forgot to take a video of plotting the points. So I'm just gonna show the final look of the Cartesian plane. So here it is, the complete sketch of the graph. So I have now another example of how to graph a function. So let me have a clean sheet of paper here. So we have y is equal to negative 3 x squared plus 8. So let's try to answer this. The first step we need to do is to make a table. So we have x as our input and y as our output. So I decided to put negative 2, negative 1, 0, 1, and 2 as my input, just to make things not so complicated. So you can put whatever values of x if you want, just like 0 0.1, 0 0.2, but in this case, I'll just make things easier. So let's try x is equal to negative 2. So we'll just substitute the given problem to the value of x, which is 2. So our answer here is negative 4. So if our x is negative 2, then our y is negative 4. So the rest of the procedure, the substituting the values of x to the given problem, I'll just make the video fast forward again. So after substituting the values of x to the given problem, now let's make a graph, I mean Cartesian plane, and plot all the points. So we have here x and y and 0 in the center. So I've run out of storage while taking this video. So I'm just gonna show the final look of the graph with the complete sketch. So here it is. And that's the end of my presentation. I hope you've learned something from me today. Thank you.
First and foremost, I would like to greet you a pleasant, wonderful day, everyone. My name is Mark Anthony G. Lagrosa, and today I'm going to present about inverse functions. So, first of all, what is inverse function? An inverse function or an anti-function is defined as function which can reverse into another function. Meaning, inverse function is all about opposite function. Given the function f of x, the inverse of the function f of x is denoted by inverse function of x. So how to find the inverse of a function? So consider the example number 1. Given f of x is equal to 2x minus 7. So the first step that you should do is you need to replace f of x by y. So y is equal to 2x minus 7. And then next is you need to switch y into x. So x is equal to 2y minus 7. So the next step is you need to transpose negative 7 into the another side of equation. So the result is x plus 7 equals 2y. So you need to able to divide it by 2 by both sides. So x plus 7 over 2 equals 2y over 2. So the result is x plus 7 over 2 equals y. So the final result or our final answer will be in inverse function of x equals x plus 7 over 2. So the next example, example number 2. F of x equals x to the raise x cube plus 8. So the first step that you should do is you need to replace f of x by y. So y equals x cube plus 8. And then you need to switch y into x. So x equals y cube plus 8. So the next step that you should do is you need to use the cube root of x minus 8 equals cube root of y cube. So you should the next step is you need to cancel out the cube root and the raised to 3, and then the remaining answer will be cube root x minus 8 equals y. So our final answer will be inverse function of x equals cube root of x minus 8. So example number 3. F of x equals 3x minus 7 over 4x plus 3. So the first step that you should do is you need to replace f of x by y. So y equals 3x minus 7 over 4x plus 3. So and the next step is you need to put denominator of 1 into x. So x over 1 equals 3y, or you need to change the value of x into y. So 3y minus 7 over 4y plus 3. So as you can see in this equation, to be able to figure out this uh, equation is you need to mul- have a cross multiplication. So 1 times 3y minus 7. So the result will be 3y minus 7. And then x times 4y plus 3. The result will be 4yx plus 3x. So the next step is you need to transpose negative 7 into the other side of equation. So and the 4x of 4yx is you need to transpose into the another side of equation. So the final result, or the result will be 3y minus 4yx equals 3x plus 7. So in this next step is you need to find the GCF of 3y minus 4yx. So the result will be y the y times 3 minus 4x, and then you need to copy the 3x plus 7. So 3x plus 7. And then you need to divide 3 minus 4x by both side, and then you need to cancel out 3 minus 4x and 3 minus 4x, and the remaining will be the the y equals 3x plus 7 over 3 minus 4x. So our final answer will be the inverse function of x equals 3x plus 7 over 3 minus 4x. And that will be the end of our presentation. Hopefully you clearly understand my topic and you learn knowledgeable things. Thank you so much.